Hello, welcome to all. Okay, now let us see how can we get two laser like sources from an ordinary bulb. Okay, it is very interesting to see, but this happened very long back due to Young. Okay, scientist named Young. Okay, see, in order to understand this, we have to know the basic properties of light. See, actually, what were the theories of light? Okay, the Newton proposed the corpuscular theory of light. That means he assumed that the light is emitted in the form of particles. Okay, that is what the corpuscular theory of light. Okay, so he assumed that light propagates in the form of particles, but at the same time, okay, another scientist named Huygens proposed the wave theory of light. That means, according to the Huygens, light is produced in the form of waves. Okay, and he also assumed that the light is propagated as waves through the medium. He assumed the light just like a sound. Okay, we know that the sound waves propagate through the medium in the form of compressions and ray diffractions. Okay, if those waves are longitudinal waves. Huygens assumed the same thing for the case of light also. He assumed that the light also propagates through some medium just like the compressions and ray diffractions in the medium. But here one hypothetical medium was ether. Okay, ether was assumed to be the medium for the propagation of light. Okay, of course there is no ether. Today every one of us know that there is no such hypothetical medium called ether, and furthermore we also know that there is no need for any medium for the propagation of light. Okay, this is different thing. We know today all these things, but in those days no one was aware of all these things. So Newton proposed the corpuscular theory of light in order to understand the phenomena exhibited by the light. Okay, at the same time, during the same period, Huygens proposed the wave theory of light. Here the Huygens assumed that the light is emitted in the form of the waves and also propagated in the form of the waves. Okay, here this is basically about the nature of light proposed by the two great scientists, Isaac Newton and Young. Okay, here we have to know all these things in order to get two laser like lights or the sources from one ordinary bulb, one ordinary source with tungsten filament, okay, or whatever it may be. Here it is amusing to see that how can we get two laser lights out of one ordinary light. Here the theoretically and practically it is possible. Okay, here what Young did, okay, in those days was he was slightly favorable in case of the Huygens theory. Okay, just tilted towards the Huygens theory. Okay, he thought that the light propagates not in the form of particles. Okay, light is not produced in the form of particles, but as Huygens said, the light is assumed to be propagated in the form of waves and also produced in the form of waves. Okay, this was the idea conceived by the Young in those days. That means here the Young for the first time confirmed that the light is produced in the form of waves and propagated in the form of waves. For this he proposed one experiment. Of course, he also conducted that experiment. Okay, all of us know that that experiment as Young's double slit experiment. Okay, he conducted that experiment in 1801. Okay, Yeah, this is a very famous experiment. Here whatever we are discussing is the classical picture. Okay, even after the emergence of quantum mechanics, it plays a very key role. The double slit experiment plays very key role. Why? Because Feynman proposed some thought experiments with this double slit experiment. Okay, right. Here let us confine to this classical picture. Okay, the experiment which was proposed by the Young in those days. Okay, yeah, actually Young utilized the sunlight as a basic source, primary source of light. Okay, what he was done is, see, this is a say one source, otherwise you take this as a sun, the rays are coming like this. See, what he did was, see here, see, after this source he just placed two slits, but actually whenever he performed his experiment he just placed one strip. Okay, just like this. See what this strip is doing here, or somewhat the piece of a cardboard, you may assume this. Okay, he just placed this strip, okay, in the path of this light coming out from this source, sunlight. See, half of the light is some of the light is going through the above portion of this strip, and some of the light is passing through this bottom of this strip. Okay, here what is happening is, see, when he also observed the resultant pattern on a screen. See, what he observed on the screen is the alternate dark and bright bands, dark and bright bands. See, what he observed here is a interference pattern. Okay, here the same pattern we see in case of a pond. Okay, suppose that there is a present pond. Okay, you drop two stones in that pond. What happens? Transverse waves, okay, circular waves start out from each stone. See, you observe the circular waves coming out of this stone. Okay, enclosing this stone. If you drop another stone, what happens here also? The circular wave pattern evolves, and as the time elapses, what happens is these two disturbances meet together. See here, we see a similar structure in this portion. Okay, that means the effect of see, one crest will be cancelled by the another throw of this another wave pattern. That may be possible here. Okay, that happens here. Okay, if one crest of this wave pattern, okay, may superimpose with the another crest of this wave pattern, then what happens is we are going to see a large crest with a great height. Okay, see here what is happening is the amplitude of the wave occasionally increasing and decreasing. At some times it is falling. It is falling very low or zero amplitude. Okay, we are observing in case of these circular waves. See, the same thing here we are seeing. See, this peak part is considered as in optical analog. Okay, this bright region corresponds to this large peak, and this dark region corresponds to this small peak. Okay, here the waves superimposing on each other are light waves in this case. Okay, where we are going to see the alternate dark and bright bands. That means low intensity, high intensity, low intensity, high intensity regions we are seeing on this screen. Okay, by performing this experiment, Young observed such a series of bands on the screen. Okay, see, he also compared these dark and white bands with the superimposed waves on this pleasant pond. Okay, so here such type of bands are possible only if light propagates in the form of waves. Why? Because we are going to see the same pattern in the pond whenever the two wave patterns are evolving over the time and combining with each other. Okay, so since you are seeing same pattern here in case of light, for that what are needed? Such wave patterns are needed. Two different wave patterns are needed here. So here the waves coming from the upper portion of this strip, okay, and the waves coming from the bottom portion of this strip are overlapping each other as they evolve in time. Then what is happening here? Here in that wave pattern, here as they evolve over the time, what happens is here the superposition of the two waves may takes place. Okay, that superposition sometimes lead to the maxima and sometimes lead to the minima. Okay, we may explain the formation of these maxima and minima in the same way as we have done in the case of the interference of water waves in a pleasant pond. See here, this is different thing. Okay, here what we are discussing here, what is our main topic, what we are discussing here, how to get two laser sources with one ordinary light. See here, what Young achieved is, here see this portion is behaving as one slit. See, this portion is behaving as another slit. Say this is slit 1. Okay, in case of this Young's double slit experiment, this upper portion is behaving as slit 1. Okay, it is allowing the light to pass through. Okay, of course these are not the lines. Okay, light here propagating in the form of waves. Okay, here actually we have to draw the waves like this. Okay, as the time elapses, the size of this arcs is going to increase here, right? Here also what is happening here, in this portion also, through this portion also, the waves are propagating like this. Okay, see what happens as the time elapses, the size of these arcs increases and those arcs overlap with each other. Okay, here see, here these waves are the transverse waves. Transverse waves. Here what about these waves? These are the light waves. Okay, these all of us today know that the light waves are transverse waves. So whatever happens here in this pond is going to happen here also. Why? Because these light waves are also transverse waves. Okay, they do have the crest and troughs, and there is a possibility that the overlapping of crest and trough, when crest and trough overlaps with each other, then you are going to see the dark band. When crest and crest is going to overlap, then you are going to see this bright band. Okay, see what is happening, this ordinary light is coming out. See, and the light coming out from this ordinary source, okay, is passing through these two slits. Okay, in that process what is happening is, this slit 1, this gap 1 is behaving as one source of the light, okay, producing this wave pattern, and this gap 2 is also behaving as another source of light. Why? Because for the interference to happen, we need two sources. Where are the two sources? This is the only one source we have taken, and all of us know that in order to interference happen, we need coherent light or coherent sources. That means what is the meaning of coherent sources? The sources are the bulbs emitting of coherent light. See what type of light is coming from this gap, and this gap coherent light is coming. Okay, so now we have two coherent sources from this one ordinary source. In this way, indirectly, Young produced the two coherent light sources by using one ordinary light source. You see the magic here. Actually, his intention was to prove that the light propagates in the form of waves. But as a byproduct, what he achieved here? He just created two specialized light sources from one ordinary source. Okay, if you think from the contemporary point of view, you come to the conclusion that Young created two coherent light sources from one ordinary bulb. He created two coherent light bulbs, something like laser bulbs, laser sources. Whenever you take the laser source, you always get a coherent light. Okay, if you take the ordinary light like tungsten filament bulb, there you are not going to get the coherent light. See here, you may ask one question. We may put two bulbs, okay, one bulb at the slit 1 and one bulb at the slit 2. Okay, then is it possible to get the interference pattern? No, it is not possible. Even though you are getting two different wave trains, okay, whenever they superimpose with each other, then you are not going to get such a stable dark and white bands. That means interference does not occur. All of us know that today. See, but whenever you place one such a bulb here and use double slit arrangement, then you are going to get the interference pattern. What is the meaning of that? Each slit is now one source of the coherent light. Something coherent light means something like laser light. Okay, right. So in this way, Young achieved the two laser like sources from one ordinary bulb. Okay, this is what the amusing thing here.